I accidentally hit stop instead of pause, so I have to do a two-part video today. Okay, the next thing I want to remind you of, two things that are on your reference sheet. The fundamental theorem of calculus, part 1 and part 2. Go back to the reference sheet. Make sure you really understand those two things. The justification sheet, I mean. Make sure you know the fundamental theorem of calculus, part 1, and the fundamental theorem of calculus, part 2, because those are going to occur a lot for these types of problems. So today's problems are really going to rely heavily on all of these justifications. All of this is huge. Okay, and then the fundamental theorem of calculus, part 1 and part 2, these two things. Okay, part 1. This one's very, very common. And they will show this, they will use this more than once on the AP exam. Okay, it's a lot of points. This one, you really need to know this. Basically, if you ever need an antiderivative of any sort, then you need to know another antiderivative. I call this starting value plus net change. Okay, so if let's say they give us, they ask us to find g of 7, okay? But in the graph, the name of the graph is g prime, okay? If they ask for an antiderivative, you go, oh, I need another antiderivative. You go look in the directions. Somewhere in the directions, there's going to be another antiderivative that they give you the value of, okay? So g of 7 would equal g of 2 plus the net change of the derivative from 2 to 7. This is then area under the curve, and keep in mind if it's above, that's a positive, below is a negative. Okay, so I want you to practice this a couple of times. Here's another one. If I gave you that the g prime graph is given, okay, there's g prime, blah, 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 and I say, find g of 2, okay? That's the question. As soon as they ask for an antiderivative, I go, oh, I need another one. What other one do they have? Oh, they gave me that g of 5 is 1. Okay. All right, so g of 2 will equal g of 5 plus the net change of the derivative from what I know goes here, what I need goes here, in that order. Okay? Then, and by the way, notice that if you evaluated just this part, okay, if you evaluate just that part, it's the antiderivative of g prime, which is g of x, evaluated from 2 to 5, which is g of 2 minus g of 5, which is the correct order if you subtract. All right, so then after you do all of that, after you set this up like that, then if these bounds aren't in order from least to greatest, then you flip it and put a negative out front. Okay, so try one more time. Okay, so write the equation you would use to solve this. K of 7, an antiderivative. We need another antiderivative that I know, plus the net change from what I know to what I need of k prime. This is in the correct order, 1 and then 7, so you would leave it. Okay? Now, then how do you calculate that? Well, clearly this is a 4, but I always leave it with a 1 and a 7 first so I can make sure that these two numbers are both 1s and these two numbers are both 7s. Okay, then you replace it with a 4, and then this is area from 1 to 7 if this is a k prime graph. Okay? All right, that's the fundamental theorem of calculus part 1. The other one is the fundamental theorem of calculus part 2. That's going to show up a lot too. This is the one that you use if you're asked to do a derivative, but the equation that you're doing the derivative of already has an integral in it. Okay? So, for example, this one right here. If I need to do the derivative of f, and I see that f already has an integral of it, then the derivative and the integral kind of undo each other, and I just get the sign of this number here. But then I have to remember to multiply by the derivative of that thing, 6x. Now, if you don't remember why it is what it is, then find my video, go to YouTube or go through Canvas and find the video called The Fundamental Theorem of Calculus Part 2, and we'll work out why it is what it is. Right now, I'm worried about just memorizing it and knowing when to do it, okay? If you need to do the derivative of an integral, okay, they undo each other and replace the t with whatever's up here. The bottom number has to be a number, but it will be. And don't forget to multiply by the derivative of what you plugged in. Okay? Also, another tip, always write what you're finding. Okay? So that you can keep track and not make silly mistakes. Make sure you give everything a name. Okay, the last thing I want to remind you of is the difference between a maximum, just a general maximum, and a maximum, but they give you a closed interval. Okay? Almost always on these free response questions, there's almost always a closed interval. Either the graph has a definitive beginning and end, or it's a word problem and it begins at a certain time of day and ends at a certain time of day. So almost always for free response questions, you're dealing with this, okay? So let me practice with what that means. Now, I don't know what K of T represents, whatever. They give everything a name, okay? But whatever it represents, let's say they ask you to find the maximum of K of T. But earlier in the problem, usually up above the problem, they say, oh, T is between, say, 2 and 8, okay? Or they'll say, you know, they'll give actual times of day, okay? So if they ask for max, you immediately, max or min, you immediately look for, is there a closed interval? And if it's free response, there almost always is, okay? So as soon as you see max of something, you say, okay, I need the derivative of that something to equal 0 or be undefined, okay? That's going to get me my critical points. You can also say, this part's optional, I'll tell you why. You can also say, because it's max, and changes from positive to negative, okay? But the more important part is, because it's a closed interval, as soon as it says max on a closed interval, you're going to write T, K of T, end points. This is going to get you more points, okay? Make sure you show that table. That's how you justify a maximum or a minimum on a closed interval. All right, next. What else goes in this table? Whatever you find over here, whatever your critical points are. That's what goes over here. Okay, let's say you have 2 of them, whatever. Okay, now this part. Usually when you have critical points, let's say it's a graph that goes like this. Usually one of them will be an obvious max, one will be an obvious min. So if you say and changes from positive to negative, then you only need to list the ones that's a possible max anyway, and you can get away with not taking the time to check this one. Okay? If you skip this part, then you have to name both of those critical points in your table. Either way, you can get full credit. Okay? But if you say these extra words, it means less time consuming in the table because you don't have to check as many points. Okay? So I suggest you say these words and do the T-chart. All right, so I know this is very sloppy and it's very hard to review when I can't see your faces. Please be honest about anything you need. Hopefully you have all of your justifications memorized before you start this. And good luck, guys. See ya.